Hello and welcome to this monoglot video where we're going to look at scraping a page that contains a whole bunch of Tony Hawk's Pro Skater stats. If you don't know what Tony Hawk's Pro Skater is, it doesn't actually matter for this video. It's a computer game from, I guess, the 90s, 2000s kind of era, although it's about to be re-released, so it's about to become cool again. But if you do know what that is, we're going to be scraping a website, which is basically taking all the information from a website, scraping all of the HTML elements, and then kind of traversing through to find the data that we need and turning it into a format that we can consume easily. So we're first going to start off in this video by just scraping this Tony Hawk's Pro Skater wiki. We're then going to create a function that just kind of returns a nicer version of that. And then in the next video, we're going to look at using GraphQL to provide an API to that data, so we can actually query different stats for different skaters. And then in the third video, we are going to look at how we would actually build a front end for that. So how we would build an application using Gatsby and Apollo client to actually consume that data in an application. Cool. So we've got a pretty packed schedule. So let's start off with just a quick plug. So this video is a monoglot video. Monoglot is a blog about JavaScript. You can find the blog here. So monoglot.dev is a blog, and you can go and look at all of our previous articles there. Obviously, this will have a little bit more, hopefully, by the time you're looking at it. But yeah, this is a nice way that we can read through and look at code examples of the different videos, and then it's got the videos themselves. If you're looking for the source code for any of the examples, it'll be under monoglot, and then whichever video we're actually looking at. So in this case, there'll be a new one called called scraping. Caching was the old one. Cool. This is the page that we will be scraping. So this page is a strategywiki.org page, which just has a list of all of the skaters. So we've got Tony Hawk, all of his stats, but it's represented in an interesting way. So we're gonna see some interesting challenges as to how we can actually pull this data out and turn it into something that we can use later. Cool. So I might start off with just an example of what scraping is. So here on the right, I've just got an empty project called ScrAPI. Also, that's a phrase that I'm pretty sure I coined. So a ScrAPI is something that goes and scrapes a website and kind of pulls out all the bits of relevant data and then exposes it as an API. So the API itself just looks like a RESTful API or a GraphQL API. But what's going on behind the scenes is it's actually live scraping the data from somewhere else. So it's a ScrAPI. I know, it's fantastic. So I'm going to create an index.js file. And I'm also going to initialize this as an npm repository. So the way I do that is I open up my terminal. It's okay if my terminal looks a little bit different to yours. You'll see that I'm CD'd into that ScrAPI folder. Then I'm going to say npm init-y. Cool. So -y just means answer yes to all the questions. So if you just do npm init, it'll just step you through each of these questions. But yeah, I pretty much want to stick with the defaults. It'll then create this package.json. And then in here, I'm going to create a start script. So under scripts, I'm going to change test to start because we're not going to write tests for this example. You should always write tests, except when you're creating examples for online. Cool. So we're going to create a start script, which is going to run node index.js. So this is basically just going to run whatever is in this file. So if we say, console.log hello, and then we run npm start from that same directory, we should see hello printed to the terminal. Cool. So I might just do a little bit of pseudocode to show you what we would be expecting when we're scraping a website. So as I said, scraping is the action of going and requesting all of the HTML elements for a page. So it's like you're scraping the whole page and dragging it back across the internet to your script. And then you can kind of traverse the tree. So it'll give you basically the DOM, so the document object model, or a collection of HTML elements in the form of a tree that you can then navigate to find the bits of data that you need. So you're probably, hopefully you're familiar with HTML. It looks something like this, and you might have a body, and in there you might have a H1 tag for Tony Hawk Pro Skater. Okay, so then we would expect that you would have like a list of characters. So you might have a section here, or we can just use divs to keep it simple. So if we had a div with like a class of skaters or something like that, and then inside that we might have a div for each skater. So we might have a H1 for Tony Hawk, and then we might have a P tag for his description of what kind of skater he is, and so on and so forth. You'll see here on the left, we've got like name, description, we've got a picture. Whoops, shouldn't have clicked that. We have whether they're a vert skater, an all-round skater, or a street skater, and then we have whether they're goofy stance or regular stance, and then we've got a collection of stats here. So imagine these are all HTML tags like this. So a good way to think of what it looks like when you scrape a website is opening up this inspector, or you can right-click and say View Page Source. So imagine we're getting back this giant collection of HTML elements, and then we're kind of moving through that tree to find the bits that we care about. But a nicer, more interactive way that we can do that is by opening up the inspector. You can do that by saying inspect element, or opening up View Tools, Web Developer, Console, and on Chrome it'll be called Console in whatever browser you are looking at. Cool. So this kind of structure is really nice, right? Because we would have a section for the skaters, and then inside that section we would expect to have a different div for each skater. And so this would be really easy to go and scrape, because we would just be looking for this div, and then we know that that div has a collection of children. So each one of those children inside there, which are these three divs, are going to represent each of those skaters. They're going to have all of the data for those skaters. Now that would be really, really easy, but we don't like easy. We like challenging. We like to learn things here. And so I've picked this website, which makes it surprisingly difficult to get any of that information. So for one, we don't have an enclosing div. So you might be fairly new to scraping, so this might, or HTML and web development in general. So this might not seem like a big deal that we have like H2, and then we have the image inside that div, and then we have the information and some images, and then we've got this table of data and a table of special moves. But then it just moves on to the next H2. So there's no enclosing div surrounding Tony Hawk and then surrounding Bob Burnquist. So each one of these, it's just a collection of HTML elements that are all the same level. So they're all siblings. So imagine that we got rid of this enclosing div, and this enclosing div, and this enclosing div, and these two closing divs. This is more like what we have. So we just have a H1, and then another H1, and then a P, and then a H1, and then a P, and then a H1. So it's a little bit harder to scrape this data, because it's not nicely organized into a table for us. Okay, so the idea here is that we want to create a function called ScrAPI, and when we call that function, we want to basically get back, so fetch HTML data, or scrape the website. We then want to transform that data. So rather than being a collection of HTML elements, we want to transform that from HTML to a JSON structure. So a JSON structure looks something like this. So we have an array, and inside that array we have a collection of objects, and each object has key value pairs. So let's say Tony Hawk. And then we might have stance is Goofy. Cool. And then we would have another object and then another object. So the benefit of this kind of structure is that in JavaScript, we can just iterate over this array and then pull out each skater. So we can, if we wanted to find what stance Tony Hawk was, it would be really easy to say, well, inside the array, I want index 0, and then I want the stance property or the stance key, which is going to give us back Goofy. So it's really easy to kind of navigate this kind of structure in JavaScript. And it's also a nice interface to provide to, if we were building a RESTful API or something like that, or even just this function, being able to call this function and know that you're just going to get back this nice kind of JSON structure is a good way to design our application. So we want to transform our HTML, so all of those elements, into the actual relevant JSON data that we care about. And then I guess we just want to return scraped data. Oh, sorry, we want to return the JSON version of that scraped data. Cool. So because we need to go and fetch something, that's going to be an asynchronous action. So we're going to have to go and fetch data from the API and wait, data from this web page, and then wait for it to come back. So because we're going to be dealing with an async action, we're going to make this an async function, which means we can use the keyword await. So when we're trying to fetch our HTML data, we can say const the data that we get back is equal to async. So wait for this thing to complete, wait for this promise to resolve, and we want to await that fetch. In this example, we could use fetch, which is built into the, it's not built into Node. So if we were in the front end, we could use fetch. But because we're in Node land, fetch doesn't actually exist. So if we were to want to go and request information from another website or make a HTTP request, we would need to install a package to do that. So my favorite package, if you've watched any of my videos so far, is Axios. So I'm going to install Axios, which just allows us to make a request, a HTTP request. So make a request to another web page. So I'm going to say Axios.get. Axios, and it's telling us that we haven't actually imported that, so we need to bring it in. Again, because we're in Node land, we're going to use CommonJS, I think it is. So const Axios equals require, and we're going to require the Axios package. If we don't do like a relative path, so like / or / something, if we just say the name here, it automatically looks in Node modules for our Axios package. Cool. So we've got Axios. We then say axios.get, and then we need a URL. So we can grab this URL here, and we can just declare that inside this file. Cool. So that's our URL. Might just make this a little bit bigger. That's our URL, so that's what we want to go and get. Oh, sorry. Sorry, we want to await Axios to go and get the data from that URL. So when we call ScrAPI, it's going to make a request to that URL. So it's going to say, Axios, go and get the resources for that URL. And we're going to wait for that to come back. And then when that comes back, we're destructuring off the data. So we would get an object back that has a few different key value pairs, but we only care about the actual data of that page. Yeah. So now if we were to say console.log data, and then we were to actually call our ScrAPI function. So here we're just declaring a ScrAPI function, which is an async function that does this stuff. We actually want to call it by saying ScrAPI open close brackets. Cool. So let's save that and let's go and run our application. And we get a whole big dump of stuff. that we are very glad we don't have to manually read through, because look at all of that. It is very messy. Okay, cool. But we are getting our data back, which is good. So what can we do with this now? Well, to kind of interpret what's actually inside this tree, or to be able to traverse this tree easily, we're going to use something called Cheerio or Cheerio. I don't know how you pronounce it, but we're going to install that by saying npm I Cheerio. I don't know. Going to install that, and then we're going to come across here and say const Cheerio is equal to require Cheerio. And then here, once we've got back our data, we can use Cheerio. So we can say const, and use $. So this is from the documentation of Cheerio. This $sign looks like it's used pretty consistently. I think this is a little bit of a nod to jQuery, which the interface is very similar to jQuery in the way that you can traverse the DOM and kind of move from one child to the next child and then its children and kind of navigate a tree is very similar to the way that you would do that in jQuery. So we're going to say we want $sign to be set to cheerio.load, and then we want to load in that data. And if we were to now say console log, well, let's find something that we actually want to pull out of here. So let's say we want to pull out, we want to find this value, so Bob Burnquist. So if we click this little thing here, and I think it's on the right hand side in Chrome, and might be a circle like a target instead of this rounded cornered square. If you do that, you'll see that everything kind of lights up, and you can navigate this page and see what you're actually looking at. And you'll see down in the bottom left here, it's actually changing, like jumping around where we are in that big collection of HTML elements as we navigate over the page. Cool. So let's say we wanted to pull out the word Bob Burnquist. So you'll see that's a span with the ID Bob Burnquist. So IDs are really easy to select in jQuery or CSS or anything like that, because the ID can only exist once on the page. So we can say we want to select. So imagine the $sign is the word select. So we want to select, and then we can give it a string that's a selector. And this selector is exactly the same as a CSS selector or a jQuery selector or anything like that. It works in exactly the same way. So if you're familiar with that, hashes are IDs, dots are classes, and then if we were just to type an element, that would be the actual element of that type. So in this case, we're looking for an ID of Bob. Let's just copy it. So if we double click on here, we can grab out that ID and we can say we want to select the ID Bob Burnquist. So if we console log that out now, if I run our application, cool, you see this massive dump of stuff. Now, this doesn't really mean much to us. We can see a couple of things here, like it's got a class of this and an ID of this, but we can't really see what the value is or anything about this actual thing. Right now, we're looking at the actual node within the tree, and this is a Cheerio element, and so this isn't actually this isn't a HTML element or anything like that. It's a special type of tree node that we get from the Cheerio library. So, but this has a couple of methods on it that we can call to do certain stuff. So here, I want to get the text that's inside of that Cheerio element. So now if I run this application, you'll see Bob Burnquist. Cool. So that's worked. And if I was to select the ID for Tony Hawk, and I was to grab this out, and then I was to run my application, I should see Tony Hawk. Awesome. So that's working. So the next problem is, because I was talking about how earlier I was saying that we don't have that enclosing div. So it would be really nice to be able to grab like an array of our different divs that represent a full skater. But we don't have that luxury here. Here we have a whole bunch of just kind of unorganized, well, they're organized, but they're not modularized. They're not moved into their own little package of a div. They're all just in the DOM. They're all at the same level. So they're all equal siblings, which is a little bit annoying. So looking at this heading, it looks like it has the ID of Tony Hawk, but it has the class of MW-headline. So what I'm thinking is we could maybe use that as an anchor point for each of our skaters, because we need to find something on the page that we can reliably select and know that we're at a certain point in the DOM. That might not make a whole lot of sense just yet, but hopefully it will. So if we wanted to say, all right, each one of these headings has MW headline next to it, and we can check Bob. He's got MW headline as the class. Cool. So we can assume that each of these headings has the class MW headline. So what if we were to, rather than select a specific ID, what if we were to select a class? And again, I'm just going to copy that so that we definitely get it right. So what if we were to grab that class and then print it out to the console? Okay, we see Tony Hawk, Bob Burnquist, Steve Caballero, Kareem Campbell. So we've got all of these skaters, and there's nothing weird on the end. So each one of these is one of our skaters. So that's awesome. So what's happened here is we have selected the MW headline class, and that's given us back an array-like structure of each of those skaters, their headline. So it's basically this span and then its children. So inside this span, we have the text Bob Burnquist, and then inside the Tony Hawk span, we would have Tony Hawk. So we've got an array of all of the elements that match this rule. So match the .mw headline. But then we're just calling .text. Now this method actually iterates through this array-like structure and turns it into a big string. So this isn't actually going to help us too much just printing out the text. But if we print out the .mw headline itself, again, we're going to see this big collection of crazy stuff that we don't really understand. So if this was an array, then we'd be like, okay, cool. If this is an array, then we can say this array dot for each element within that array, we want to console log out the element. So if we were to save that and comment out this console log, we get this. So type error dot for each is not a function. So when we select this, even though this is an array-like object, it's not actually an array. It's a special type of Cheerio collection. It's a certain type of data structure that we get from Cheerio. So this isn't actually an array. So if we wanted to get back an array of all the raw skaters, we could say const raw equals array dot from. So this can be used to take something that is, as you can see here, iterable or array-like, so anything that is similar to an array. So if we were to take this, then raw should now be an actual array, a real array, because we've used array.from, so it's going to turn this into an array, which is going to give us that for each and some other things that exist on array. So let's now try and run this. Oh, and we get this big long dump of stuff. So that's good. At least we're not getting an error, but something's going wrong here where it can't actually console log, or it's console logging it out, but this is not what we're expecting. This, again, is that Cheerio element, or the Cheerio element. We would need to call .text to get the text that actually exists within that. But now, if we were to run this, we're going to get another error. So this is something that's quite frustrating with using a library like this is even though we've got an array of these elements, if we want to actually do anything with that element, we have to select it again within the DOM. So remember this .text, if I have a look here, it's saying .text is not a function. So e.text is not a function. So this element itself doesn't have the .text method on it. So if we want to call .text on this element, we need to select it again within that tree. So we need to say $, brackets around the E, and then .text. So this is using Cheerio to select that element within that tree. And then on that selected element, we can call .text. Cool. And then we get back Tony Hawk, Bob Burnquist, Steve Caballero, all of our different characters. Awesome. That is fantastic. So that would suggest that if we select each element and call .text, we would be getting back our skater's name. So let's now actually create our data structure. So this is going to be our skaters. And for our skaters, when we do raw.forEach, we're iterating over that collection, but we're not. We can kind of only operate on that element itself within there. So we can console log out what the value is, but this for each doesn't return anything. So if we want to create a nice big structure of our skaters that have a name and blah 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 blah, if we want to create that JSON representation, then we're going to have to use something called map. So raw is our array, and then we're mapping over our array, and then as this says here, it calls whatever our callback is. So we give it a callback. It will call that function on every single element of the array, and then it'll return a new array that contains the result of that function. Might sound a little bit confusing if you're not too familiar with mapping over things. So let's just step through it bit by bit. So firstly, we pass it a callback. So I'm going to use an arrow function here. If you're not familiar with arrow functions, all this is saying is it's an anonymous function, so it doesn't have an identifier that we can call it with. So it's only going to exist during this map, and then we're not going to be able to call that function again. But that's fine because we don't care about this function outside of this map. So we're calling map, giving it an arrow function. These will be the parameters that will come in. So we're going to iterate over each skater. So the parameter that's going to be passed into our anonymous function is going to be each skater one by one. And then we have these curly brackets, which represent the actual body of our function. So we have our function here, and whatever we return from this is going to exist within this skaters array. So here we are mapping. So again, this is like a for each, where we're iterating over each element in that array. And then we want to do something with each of those skaters. So up here, we're console logging out, selecting that and grabbing the text. So here, if I want to say const name is equal to, and then I want to, again, select our skater from inside that big DOM tree, and then I want to get the text. And then down here, I'm going to return a new object, and that object is going to just have a name property. We're going to be using a lot of ES6 syntax or ES6 and beyond syntax in this video. So I'll try and remember to kind of give a quick example or give a quick explanation as to what I'm doing when I'm doing it. But here we're returning a new object. So this is a new JSON object. And then inside there we have name. And in ES6, because the identifier name is the same as the variable that we're grabbing the value from, so we're grabbing this value, rather than saying name is equal to name, we can just say name, and it automatically does that. So it'll implicitly say name is equal to whatever this is. So in our new object, we'll be able to select .name, and that's going to be equal to whatever this value was. Cool. That might be a little bit of a confusing way to explain it, but hopefully it'll make more sense as we go along, because we'll sort of be just following this pattern, building up our skaters array. Cool. So now if I console log out our skaters after I've mapped over all of them, hopefully we will have an array of objects that contain each skater's name. Awesome. Cool. So we have our array, our outer array structure, and inside that we have an object with a name for Tony Hawk, we have an object with a name for Bob Burnquist, Steve Caballero, and so on. Cool. So now we can kind of follow that same pattern and build up our skater. Okay, so the next thing we might want to grab is this image. And one way that we could do this is by selecting based on a class or an alt tag or something. But you see here we have this image, but we don't really have anything that's going to be the same across all of the different images that we have for skaters. I guess we could go based off the width. So if an image had precisely the width of 234 and the height of 256, but that seems like a very brittle way to be finding all of our image elements. We don't know that that's not going to change on bigger screens or anything like that. So I think I vote that we don't select that directly. So there's not really anything personally identifiable about this image that says that it's a skater image or something that's general enough for all of the skaters. You'll see here the alt tag is specifically Tony Hawk. So this image is specifically for Tony Hawk. This one is specifically for Bob Burnquist. So when we were looking at the title, we had an ID that was that same thing. So ID for Tony Hawk, ID for Bob Burnquist, so on. But we had this class, which was a general thing that existed on all of those skaters. So anything that had the class MW-headline, we knew was the actual span that contained our skater's name. So we don't have that for an image, but we can pretty reliably know that if we were to select this span and then go up to its parent, this H2, then if we were to call .next, we would be on this div. And then if we were to look at the div's children and select the first child, we would be looking at this anchor tag. And then if we were to look at that children's first element, we would be looking at this image. So if we have this anchor point for this H2 and we know how many steps each bit of data is going to be from that H2, then we could select all of the H2s and then iterate from that point, grab all the bits of data that are related to that skater, and then move on to the next H2 and grab all the bits of data that are related to that skater. So this would give us a way to navigate through, but give us an anchoring point, that first point where we find out who the skater is. Hopefully that makes sense. Okay, so the next part that we're going to try to do is we're going to try and select, if we have a look at this image, there's this source here, and if we were to open that up in another window, that's not going to work. If we were to say https:// that stuff, we get Tony Hawk. And if we were to look at that same structure for Bob Burnquist, we would get Bob Burnquist. So we want to have a collection of URLs that we can go and get those images from. So if we again start from our heading, and then we call .parent, we'll go up to this H2. So let's say const image is equal to And then again, we're going to select our skater. So this is going to be our starting point. We're going to select that span. And then we want to move up to that span's parent. And then from the parent, so we're at this H2. So from the H2, we want to go on to the next sibling. So we're going to call .next. And then that gives us this div. And we have this div with all of its children. So really, we want to select something based on this href here. So one thing we can do is we could use .children and get all of its children and then iterate through those. But for this one, I'm actually going to use .find. So if we have a look at find, it doesn't give us much of a example, but basically we can pass find another selector. So similar to what we had here, we're selecting based off a class. So here we could select based off a type of element. So we want to select an image. So this image here, and we want to basically look at the source attribute. So we want to get this value here. So if we find an image, so again, I didn't mention before, but .find will basically give you a deep find. So right now we are selected on this div. And so .find will look recursively through each one of the children within that little isolated piece of the tree and find anything that matches that selector. So here I want to find the image selector and then I want to select its attribute for source. Cool. And now let's just follow this same sort of convention we've got going here, where we declare the part that we want to select, and then we return it as part of our skater object, and then we'll be console logging out our skaters. So this will give us a way to kind of debug what's going on or check that each part is working correctly. Cool, awesome. So we have an image, which is a string, and it gives us this big thing. But you would have seen before when I try and navigate to just // it was giving me an error that it would automatically try and look for a file that was located at that location. So we actually need to prepend this with HTTPS. So it knows that we're actually going, we're storing a full address that we could go and get that image from. So one way we could do that is we could call this image raw, and then we could say const image. So our clean version of our image is going to be HTTPS. And you'll notice here I'm using these backticks. So backticks allow us to do what's called string interpolation. So basically we could access a variable. So if we had like name or something like that, we can access the name within this, and it'll take the string version of that and insert it into our string. So, I mean, if we were to do this here, image would be equal to HTTPS and then Tony Hawk. So that's not what we want. But what we do want is we want to say HTTPS and then colon, and then remember this image raw was the // cdn blah 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 blah. So it was all of this stuff. So // da 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 da. So we just want the remainder of that after HTTPS colon. So we can put image raw here. And now if we rerun our application, awesome, you'll see that we get an image, and then let's say we wanted to look at Spider-Man, who's one of the secret characters in Tony Hawk's Pro Skater. If I copy that URL and come here and paste it in, you'll see I get Spider-Man with his awesome skateboard. Cool. All right, so that part is working. We have the Tony Hawk, we have his image. I don't really care about the description, but I want to select this image and work out whether Tony Hawk or whether any of our skaters are vert skaters, all around skaters, or street skaters. So they're the three options. So if I click on this image, so it's a p tag. Inside the p tag, we have an anchor tag for the image itself that we can click. We then have an image inside that, which is the image of the actual that logo. But you see, we don't have any text here, so there's no. It doesn't tell us the type is vert. Yeah, so this is going to be a little bit difficult to select in the same way that we've selected our other elements. This one had the actual text inside that the span element. This one we needed to navigate to the image, but then we could grab the source attribute directly, and that basically gave us what we wanted. But here we want to know whether the stance is vert. Oh, sorry, not stance. Why do I keep saying stance? Let's say type. We want type to either be equal to vert, or we want it to be equal to street, or we want it to be equal to all around. So there are many ways that you can do this. The way that I'm going to step through, we are going to use, what's something that we could use on this? So if we have a look at this vert icon, I've got an alt tag that says vert icon, and also in the source, it says vert icon.png. And if we were to select this all round, we can see that, again, in the alt and the source, it has the word all around. And if we look for a street skater, it has the word street and street. Okay, cool. So we could possibly select this image and then look at the source, which would give us this big string. And then maybe we could look inside that string for an actual word, street, vert, or all around. So why don't we try doing that? So firstly, we're going to start, like we're going to start from all of our examples going forward. We're going to start from the H2. So this H2, not that H2, this H2. We're going to start from the span, and then we're going to go up to the parent. So let's start from our skater, which is that span. We're then going to go up to the parent. So now we're at the H2. So now how many nexts do we need to do? So we're here. We want to go next to get to the image, next to get to this paragraph, and then next to get to this p tag here. So that's where our type is going to exist. So we call next dot next dot next. I think it was it 3? H2 next. Cool. So now we've got this p tag, and now we want to look inside that p tag for. In this case, because we've got the p tag, and then we've got an anchor tag with an image in it for the vert icon, and then we've got an anchor tag with an image in it for the stance. So we can't just select an A with an image in it and look at the source like we did for the image, because this has multiple children. So in this case, we're going to select children, which is going to give us an array-like structure of this A tag and this A tag. So we have these two within that array of children. And then we're going to look at dot first. So that's going to give us the first child. So then we've selected this A. And then we want to, on this A, we could actually just grab the href directly off this. So we wouldn't actually need to go any deeper than this. So why don't we just grab the attribute for the href? So again, dot attribute for the href. And then, because we've done a lot of stepping through different layers, let's just make sure that we're actually getting back what we're expecting. So hopefully if we've started at the span, gone up to the H2, gone across 3 children, and then, gone across 3 siblings, and then gone down to the children, and gone to the first child, and selected the attribute for href, we would be expecting this href here. So /wiki/file thp to do verticon.php. So let's save our application. You'll see I've got Prettier running here, so it's automatically moved all of these onto a different line. It's okay if yours are all on the same line, or you can put them all on a separate line, whatever you prefer. So I'm going to run the application now. And we get a warning that I'm not running the latest npm, which is fine. But yeah, you'll see here type. We have this wiki, street icon, street icon, street icon, street icon. So you'll see vert icon, all around vert icon. So yeah, we're getting back the path, that source, href path that we asked for. So now this is a big string, and we probably want to check within that string, do we have the word vert, do we have the word street, or do we have the word all around? So again, I'm going to rename type to be type raw. So this is the full string of our type. I also might just add a couple of extra lines here so we can see how we've grouped things. And then I'm going to say const type is equal to I'm going to pass this up to a function. So I'm going to create a function called getType, and I'm going to pass in type raw. So we now need to declare this function for getType, which is going to take in a string, so that big string, and check whether any of our three cases exist within there. So I'm going to say const getType is equal to, and then this function is going to take in, I guess we could call it a href, or we could just call it string. And then we want to check each of our conditions. So we want to use an if statement for this, or a collection of if statements. So we're going to say if our string dot includes, so if that big long string includes the word vert, then we want to return just the string vert. We could then just check that this is actually working by saying if it doesn't contain vert, we just want to return unknown. Also, the reason that we don't need to use an else here, like usually if you were using an if statement, you'd need to say if something, then do this, else do this. But because we've got the return keyword here, it's actually going to exit the function straight away. As soon as it hits this return keyword, it's going to return vert. So if the string does include vert, it's going to immediately return with the value vert. So the only way that it could actually get to this return statement is if it's not vert. Okay, so again, we have type raw, which is grabbing the raw value from that href, which is that big string. We're then calling getType and passing in that raw version of the type, so that string version. GetType is going to check if the string includes the word vert, then return vert, otherwise return the string unknown. And then that type is what we're returning from our Skater object. So if we run our application now, awesome, we see unknown, 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 unknown. And that might trigger some panic, being like, oh god, we didn't do it right. But you'll see here we've got vert, and here we've got vert, and up the top we should have vert. So it's actually working the way that we're expecting, because we're only giving it one condition for vert. So now let's add our other conditions to that function. So let's say, actually I might just copy this 3 times and say, I'm going to double click here to select vert, and then you'll see the word vert lights up everywhere. So then if you do Command D in VS Code, it will select the next occurrence of that. So I'm going to say I want to change this to street. So if the string includes street, I want to return the string street. And if it returns all around, so because this is a big, if we find one of the all-round skaters, all around, you'll see that in this file, it says all around, obviously with no space, but we probably want to return a nice formatted version of this with a space there. So we're going to check whether the string includes all around with no space, but if it does, we're going to return all around with a space. And then again, if none of these conditions match, we're going to return unknown. And this is just to protect, like we're expecting that one of those will always exist, but this is just to protect our application from crashing. Because if they were to add a new stance in the new version of Tony Hawk that's coming out soon, then we would want it to set it to unknown, not undefined. All right, so now we run our application. Awesome. We get back street. We have street, vert, all around, vert. Awesome. So we've got all of our different types. So now we're going to do a similar thing to grab out the stance. So I suggest at this point you either take a break or maybe let some of this sink in, but maybe try to actually complete this on your own. So if we've got the type here and we're calling a function for getType, how would we modify that to get the stance from the player? Cool. I mean, I know you didn't pause, but we can just step through it now. That's fine. All right. So again, this is within the same p tag. So we have the p tag, and then inside that we were selecting children, which gave us back this array of these a tags. Sorry, I can show you where we're doing that here. So children gives us back that array-like structure. And then we were selecting the first child, which is going to be this a tag. And then we were looking at the attribute for href. So why don't we do a very similar thing? In fact, we could do this in a super similar way. So let's just copy all of this. So rather than type raw, this is going to be stance raw. And then rather than get type, we're going to call get stance. So we're going to create another function that can do that. And we're going to pass into it stance raw. And then we're going to get back a stance from that, which is what we're then going to pass across or return from our object of skaters. Cool, stance raw. So we're going to have to modify this slightly. So if we think about how this is working, we're selecting the parent, which is the h2, navigating across to the p tag. We're then looking at the children and grabbing the first. So the easiest way to modify this is just from the first, why don't we just call .next? And then we would be moving to the next child, which is that next a tag, this one here, and then select the href. So that's probably the easiest way that we can do it without modifying much. And then for our get stance function, again, let's just copy all of this. We'll modify this to get stance, and then we want to check whether the string includes. Now there are only two stances in Tony Hawk. So there's Goofy and there is regular. So we just want to check whether the string includes. Again, I'm going to select both the verts and say regular. And then I'm going to select both the streets and say Goofy. And then we don't actually have a third option, so I'm just going to remove this, but I'm going to leave this unknown. So we've got that fallback if for some reason they create another stance that's not regular or Goofy. I don't know how that's possible. If you know anything about skating, I guess you could stand both feet like hang 10 style side by side and move forwards. That might work, but you'll probably stack it. Okay, cool. So that should work now. We've got our stance raw, which is selecting from the previous selection in the type, we're then just moving to the next element, selecting its href, and then passing it to get stance. And so stance should be equal to either regular or Goofy, and then we're returning that from our object. So let's run this now. Awesome. So we've got regular, and then up here we've got some Goofies. Goofy. Awesome. Cool. So we've now got our skater's name. We've got an image for our skaters. We've got what their type is, so whether they're vert, street, or all-round. And then we've got their stance, so whether they're goofy or regular. So the next thing we probably want to pull in is this stats table. If we have a look at this stats table, so this is the full table, you'll see inside there we have a T body, and then we have these TRs, and each of those TRs has a TH, a TD, a TH, and a TD. So this might seem super simple because it's just a table with a collection of values, so we should be able to iterate over that and grab all of those values out. But I think there might be a couple of little gotchas here. So again, I recommend pausing the video here and trying to attempt this on your own. I'll show you what we're trying to achieve. So basically, we want a stats object, and inside that stats object, we want to have air, or it can just be capitals to make it easier, air, and then we actually want to work out what number of stars, filled in stars, we have here. So here we've got 1, 2, 3, 4, 5, 6, 7. So we want it to be the number 7. And then for hang time, or let's select landing. So the next one across, we have 1, 2, 3, 4, 5. So we want the number 5. Cool. And then we would be passing stats or returning stats from our object as well. So give this a go on your own. See if you can work out how to navigate from the heading down to this table and then traverse the table to pull out those values. And I will take you through an example of it in a second anyway. Okay, cool. Hopefully you gave that a little bit of a try yourself and maybe ran into a few of the little bits of complexity in this example that maybe weren't so obvious to begin with. If not, we'll step through it now and we'll definitely see them. So the first thing we want to do is actually select this table. So I'm going to start from the same place again. Start from the span, go up a parent, and then I'm going to need to go next, 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 next to get to this table. So that's for next. So I'm going to say const stats is equal to, and then I'm probably just going to copy at least this much of the previous statement. So I'm selecting my skater, which is that span. I'm going up to the parent, which is the H2, and then I want to go 4 siblings across. Cool. So now I should be at this table. So inside the table, I can see that there is this T body, and then inside the T body, there's a collection of TRs. So each of these TRs has 2 sets of stats in them. So I want to get an array of these TRs to begin with. So if this is the table, then I want to find within the table something that matches the selector for T body, and I want to do what's called a direct descendant selector. So it's going to look for a T body, and then it's going to select all of the TRs that are immediately descending the T body. So only things at this level. If we had more TRs inside one of these TRs, they wouldn't be selected. So it's just any TRs that are immediate children of the T body. And again, this is going to give us an array-like structure, but not the array itself. So I'm going to wrap that in an array.from. And then I'm just going to console log out stats.length. So again, like each stat is going to be that big Cheerio element thing that looks a bit ugly, so we don't really care about the data within it. We're just checking the length of this array to make sure that we've actually got, well, 5. If we have 5, we can assume that we've got the right thing. I'm also going to comment out this console log skaters because we'll probably focus on stats for a little bit. I'm going to run the application again. Cool. whoops, sorry, clicked out of that. We got back a bunch of skaters, which doesn't seem right. So let's just have a look here. No console logs there. Okay, maybe, oh, sorry, I didn't save. Let's run that again. Okay, we get back 5, 5, 5, 5, 5, 5, 5, 5, 5. Cool. So that's what we're expecting, because for each one of those skaters, they all have a T-body, and then inside that, it's got 5 children. So this gives us back those elements, and then we turn it into an array, and then we're console logging out the length of that array. Cool. So the next thing we need to do is right now, you can imagine one of our TRs to look something like an array, and inside that array, it has air, and it has our stars, and it has landing, and it has those stars. So this is kind of what we're getting back from each row of this stats array. So if we were to iterate over the stats array, each row would be an array like this. So air, numbers, landing, numbers, and then the next array would be hang time, numbers, switch, numbers, and then the next array would be ollie, blah, 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 right? So we want to take that kind of structure and turn it into one big object where we have these key value pairs. So here we have air, and then, so that's kind of like key number 1, and then we have the value number 1, and then we have key number 2 and the value number 2. So what I mean is we want this to be represented like one big object rather than a collection of arrays, and in that one big object we have air, and then we have the number of the actual stars, and then landing, and then the number of those actual stars. And so on and so forth. So we want to collapse all of these arrays. We want to collapse them all into one big stats object. And so the best way we can iterate over a collection of things and then turn it into one big other thing is using a reduce. So I'm just going to comment this out so we can have it here as a reference if we want to look at that structure again. But let's say stats. Again, I'm going to follow that same pattern where I'm going to say this is the raw version, and then we will create the actual stats object that we want to return. So let's say stats raw.reduce. So what this takes is a callback. So again, this is just like a function where we can do things. We get some parameters, and we can operate on them. And then the second parameter that we pass to a reduce is a default value. So you know how I said we're taking one type of structure and turning it into another structure. So .reduce will return us a new thing. Now, if stats raw was an empty object, we need to tell it what to actually return. So we need to give it a default value. So if we were planning to sum up a collection of numbers, this might be the number 0 because we haven't got any numbers yet. If we were going to iterate over some kind of array and return a different array, it would be an empty array. But because we're expecting to get an object back, this is going to be an empty object. And then there are two values or parameters that are passed into this callback by reduce. The first one is an accumulator, and the second one is the actual object that we're iterating over. So the actual stat itself. So the accumulator can be thought of as kind of like a running total. So in that example before, when I said if we were summing up numbers, this would be the total of the numbers as we're iterating through the collection. So it's sort of building up one big value that you then return from the reduce. So whatever we return from this iteration of the reduce will come in as the accumulator of the next element. So we always have the previously returned value and then the current element that we're iterating over. Cool. So it can be a little bit tricky to get your head around. But basically we're going to be building up this accumulator object which starts off as an empty object, and then we're going to build that up and build that up and build that up until we have this kind of structure, and then we're going to return that from the reduce. So we need somewhere for that to go when we return it. So let's say const stats equals that, and then we can change this console log to just console log out our stats. So then we can kind of look at what's what we're building up over time. Let's just run our application and see what we're getting. Cool, so we get undefined, 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 undefined. So what's going on here is the first time we call reduce, we're giving it an empty object, which comes in as accumulator. But then we're not actually returning anything. So really we're returning undefined. So then accumulator is overwritten with the value undefined. So if we were to return anything from here, if we were to return the string reducing, then even though accumulator starts off as an object, because we're returning a string, it's just going to make all of those values the string reducing. So whatever we return from each iteration becomes the accumulator that gets passed into the next one. And then when we get to the end of the reduce or the end of the array, that's when we return that accumulator value and it becomes stats. Okay, so what do we actually want to do in here? So remember, this is iterating over each one of these TRs. So each one of these TRs still has a collection of children inside it that we then need to work out what they represent and then add them to that accumulator. So let's start off by grabbing all of the children within the TR. So I'm going to say const children. I'm going to call this children raw because we're going to do it in two different steps. So firstly, we are going to select that particular stat. So the one that we're currently iterating over, we're going to select that within our tree. And then, so that's going to give us this TR. And then we're going to call .children on it, which is going to give us these values. Cool. So again, that gives us back something that is array-like, but we probably want to do some more array-type things to it to be able to pull out those values. So let's say array.from. Let's wrap it in another one of those array.froms. So now children raw should be an array of each of these weird Cheerio elements. So then we would need to iterate over each one of those raw children. So we want to map over each one. And for each of those childs, for each child, we would want to call child dot text to get back that text value. And again, map is going to return us something. So we're mapping over all of the values in children raw, and we're returning .text from each one. So we will get back an array of all of those child texts. So we need to put those somewhere. So let's say const children is equal to children raw.map, blah, 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 blah. We can leave this reducing for now because it doesn't really matter until we start building up our accumulated values. But let's just console log our children out. I'm just going to give it a little bit of space. And let's just comment out this stat so we don't just see reducing, 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 reducing. So now what we expect to see is an array of each of those values or those keys and values. We are getting child.text is not a function. So we remember seeing this from earlier. This is because, again, we've tried to just call .text on this child, whereas we need to select the child first. So let's wrap that in $sign brackets. So we select the child, and that gives us access to this text method. Okay, awesome. So we're getting all of those bits. So we're getting those arrays of those different values. So we've got all of those different children. You'll see there's some \n stuff here. So what that represents is a new line character. So it'll go onto a new line. We probably don't want to return that in our version because that probably just has something to do with how they're choosing to display it on the site. So we can actually, because .text is going to give us back a string, we can actually call .trim. trim on that string, which, as you can see, removes the leading and trailing white space. So any kind of white space character, a new line or a space or whatever, will get removed from that string, but only the start and the end. So now if we run our application again, cool, we've removed all those \n's, which is good. The next thing we want to do is for each one of these arrays, so here this children is an array of each of those values. So we've got this key and value. So what we want to do is we want the key Ollie to then map to the value 5. And we want the key rail balance to map to the value 6. So what we can do here is we can pull them out of the array. So there are two ways that we could do this. We could do this the cool ES6 way. So I'll show you how to do that, but then we're actually going to do it the old way. But firstly, what we can do is we can, because children is an array, and we want to declare index 0 as key 1, index 1 as value 1, index 1 as key 2, and index 2 as value 2. Oh my god, that's hard to say. We can destructure them directly from the array. So we can say, cool, I've got my children array, and then I want to pull off the first value, and then the second value, and then the third value, and then the fourth value as key 1, value 1, key 2, value 2. So now let's have a look at what one of those objects would look like. So if we console log out a new object that has key 1 is set to value 1, and then we run our application again. Okay, so we see key 1, key 1, key 1, key 1, key 1. So something's gone wrong here, and that's because anytime we use letters here, it's going to explicitly set this as like key 1 is the actual key, whereas we want it to look up what string is stored in key 1, so air or landing or hang time or switch or something like that. We want it to grab that string and then dynamically set that string as the key. So all we need to do is just wrap this in some square brackets, and then if we run our application again, we should see something different. Okay, awesome. So this is what we want. We see Ollie, speed, spin, air, hang time, and each of those map to a particular star value. So looking at this, there are a couple of problems here, right? We've got, firstly, these are all stars. That's a confusing way to represent these numbers. We want to pull out the actual numbers. But also, these keys aren't really consistent with the rest of our application. If we have a look at how we're representing like our Skater object, we have name, image, type, and stance. These are all what's called camel case. So that's where the first letter is lowercase, and then any other words after that would be uppercase. You can't see it here because they're all one word variables. But here with stats raw, see how we've got a lowercase first letter, and then uppercase for each word after that. So we've got a couple of problems here. Firstly, they're not lowercase for the first letter, but then some of them have this space. And when there's a space, it's now wrapping it in quotations because it can't have a space in an identifier, in a key identifier. If we want a space, we have to set the key to be a string. So it's automatically doing that for us, but we don't want it to do that. We want a lowercase h, and then we want to remove the string, and we want an uppercase t. So to do that, we're going to write our own function that can camelize our keys. So so let's firstly write that function. So I'm just going to call it camelize, and that's going to take in a string, and then it's going to do some stuff with the string. So we can use that magic destructuring that we just saw, the array destructuring that we just saw, where we could, well, firstly we need to turn the string into a an array. So if we call string.split, what this will do is it will split the string at a particular character and then give us back an array. So it kind of turns a string of words into an array of separate words. So we want to split on the space character. So anytime there's a space, anytime there's a space in that string, we want to strip the space off and then move that word into a new index of the array. It's a confusing way of explaining it. Let's just say const array equals string.split that, and then I'm just going to console log out array, and then I need to call camelize somewhere. So down here, I'm just going to say, I'm going to comment this out for a second, and I'm just going to say camelize, and then I want to camelize key 1. Cool. So this is what it does. For any space where there's just one word, it's just an array with that one word in a string. But anytime we had like hang space time, it's now given us array with hang as the first index or index 0, and then time as index 1. So it splits up a string into an array. So that's good. So we've got this array which has all the different values, but we kind of only care about about changing the first value. So the index 0, we want to always set the first letter to be lowercase, and then the rest of the words can have an uppercase letter. So where we've got array here, we could actually destructure out the first bit, and then we could spread any other values that we get into a new array called bits. So this will pull off the first value. So in that case, in the case where there's only one, it'll just be Ollie, and then bits will just be an empty array. But in the case of hang time, hang will be set to the variable first, and then there'll be an array with time in it and any other words that might be in that sentence. Yeah, they come in as bits. Okay, cool. So now we want to return basically a new array that contains our first word, but we want to turn that into a lowercase word. And then we want to take all of those bits and spread them back in. And again, in this case, it's only going to be one extra word in the case of like hang time or any of those ones that have 2 words. But this function would be reusable for any number of words. Like we could use this camelize function to turn a massive string of words, massive sentence of words into the camelized version of it, or the camel case version. So we're then going to call, because we don't want to return an array from this, we want to return a string. Like we want to give this function a string that's in one form, and we want to get it back in another form. So we're going to call the opposite of split, which is join, and we're going to just join them up with no character. So this, we could specify like a comma or a space or something like that, and it will join up the string with that character in between. But because we're actually wanting to remove the white space characters, we want to remove those spaces, we're going to join it with no character. So this is going to take this whole array and turn it back into a string. So again, split will take a string and turn it into an array of all of those words, and then join will take an array of those words and turn it back into a string. Cool. So now we're calling camelize key 1. So maybe I'll just go back to our console log, and here I'm going to call camelize around key 1 just to make sure that we are getting the right value. Cool, awesome. So we can see here that Ollie, speed, spin, air, they're all lowercase, and then hang time, which was 2 separate words and then wrapped in a string, is now our nice camel-cased version of that key. Awesome, so that's working. So the next thing we need to do is do a little bit of calculation on the value as well. So this type of destructuring was nice if we didn't need to further transform those values. But because we're going to need to operate, we're going to have to turn this into the camelized version, and then we're going to have to turn this into the number version of those stars. We probably want to do this in the long form version, which looks more like this. So const key1 equals children index 0. And I'm just going to copy that a few times and say value1 equals index 1, key2 equals children2, and value2 equals children3. Cool. I'm then going to wrap our keys in that camelize function. So it's going to pass that value immediately to camelize, and then we're going to get back the nice camel case version of that string, which we're going to set to our key1 and key2. So again, let's just make sure this is working. So I'm going to remove camelize from there. And I might also console log out key2 and value2 just to make sure there's not anything weird going on there. Cool, awesome. So now we have our all of our different stats. So air, landing, hang time, switch, ollie, rail balance, speed, lip balance, spin, and manuals, and then their star representation. So let's take that star representation and turn it into an actual number. So for this, I'm going to use match. And so match allows you to pass it a regular expression, and it will give you back an array of every time that value was matched. So the way that we do a regular expression is between two slashes. This might look a little bit weird if you haven't done many regular expression things, but it's not that scary. And then see how we've got each of these stars. I'm actually going to double click one of these and copy the character from our dev tools, so from the inspector. I'm going to place that in here, and we can see that we actually get that character, which is awesome. This blew my mind when I was working through the example for this. I didn't realize you could do this. So children index 3, that's going to give us that string of stars. We're then calling .match on that string and giving it a regular expression. We then need to add a combinator to this, because this will only match on the first time it finds this, and then it will stop running. But if we put a G after that last slash, then it will run globally across the whole string. So we'll get every single match of star. So this statement here will give us back an array that looks something like this. It will contain however many filled in stars we have, but it will ignore this not filled in star because that doesn't match this character. Which means this array that we get back from this statement will actually contain the number of times that we have a colored in star. So if this is an array, we could just call .length on it and get back the actual length of this, so 3 in this case, which would give us the actual value that we want to provide to our user. So let's take that same statement and put it on value 1. And our console logs should still be working the same way. So now if we run this, instead of seeing these stars, we should see the actual number. Awesome. So we see the actual integer representation of that value. So now we're only one step away. We've been able to kind of build up these two separate objects that we want to spread into this larger object. We really just need to now deal with our accumulator and adding these values to the accumulator each time. So if you can imagine, the first time we run this reduce, so on index 0 of our stats array, accumulator is going to be an empty object. So what we want to do is we want to take that empty object and we want to add in these two objects that we've now created. Or we don't want to add in the objects, we want to spread these parts into that object so that we get this nice big object of just key value pairs, all the key value pairs for all the stats of this particular skater. So we want to return a new object and we want to spread in whatever we have accumulated so far so whatever previous iterations have created, and then we just want to take this key1 statement and this key2 statement and add those to the array. So what this is doing is it's spreading in any previous values that we had, and then it's adding in key1 value 1 and then adding in key2 value 2. So this should be building up one big object of all of those values that we've seen in each iteration of the reduce. So now if I uncomment this console log, so console log stats, so this is going to console log out the result of this reduce. If I run this now, we see a full object of stats for every single player. So if we go back up to where we ran it, yep, so this would be Tony Hawk, this would be Bob Burnquist, this would be, I don't remember from that point, I only remember 1 and 2. Cool, so our reduce is working correctly. So now all we need to do is actually return our stats from this map that we're currently within from way up here. So we're also giving it the stats. I'm just going to remove this stuff so it's a little bit easier to reason with and save. So now if I console log out skaters, we should see as we run, so this is going off, it's scraping the HTML from that page. It's bringing that back. It's then transforming it. So it's going through and it's finding where's the name, where's the image, where's the type, what are the stats, and it's putting all of those into one big giant array of objects. So if we scroll up a bit, we have Tony Hawk, we have his image, his type is vert, stance is goofy, and then all of his stats, and then we've got Bob Burnquist, Steve Caballero, and so on. So this is finally working. The last thing we need to do is, rather than console log this, we want to return our skaters. And then we should have done each of our steps. So remember, our first 3 steps were fetch the HTML data. So here we're fetching the data, we're giving it to Cheery.io so that we can then traverse that tree. So we're creating a big tree of HTML elements. We're then creating an array of each of our skaters. We're then mapping over all of our skaters. So we're transforming that HTML to JSON. So we're mapping over all of our skaters, getting the name, the image, the type, the stance, and the stats. And then we're returning one big object for each of those skaters. And then we're returning the skaters from this function. So now anytime we call scrape, it's going to run this function and go through, scrape the site, transform it into the data that we actually need, and then return that data to our user. Awesome. So that's everything I wanted to go through in this video. In the next video, we're going to look at building a GraphQL API. So we're going to look at building an API in front of this so that a consumer can say, I would like to see all the skaters, or I would like to see this particular skater with this name, for example. So in the next video, we're going to look at doing that. And then in the final video of this series, we're going to look at actually building a front-end application using Gatsby and Apollo client to actually request this data and then display it on a page. Again, if you want to look at any examples that we've gone through, if you go to github.com/monoglot, this will have all of the different examples from the blogs and video series that I've done. So there'll be a folder in here for ScrAPI by the time you have a look at it. Also, if you want to go to the Monoglot blog, this is a really simple way that you can go to one of these examples and actually copy the code and then paste it somewhere else. But yeah, it usually just steps through a text example of what I've gone through in this video. But yeah, if you want to like and subscribe and do all the fun YouTube stuff, and if you want to check out any of the other videos in this series, they will go through hopefully as interesting stuff as this. Cool. Thanks for watching. Have a good one.